Hello, I'm Roman. Welcome back to a series of the videos of building the convolutional neural networks from scratch. And this series is based on my previous series of building neural networks from scratch. So I'm using the code that I built there to implement the convolutional neural network. Well, specifically, I'm trying to build the convolutional layer, the MaxPooling layer, and in the end, I'm going to create a different model architecture to solve training against the fashionist dataset, which we used in the previous video, well, in the previous series as well. So right now I'm implementing the backward paths, and I'm actually going to change, I'm going to implement the backward path, and then I'm going to change the way I implemented the forward path, and well, hopefully that should be enough for this video already. So let's start. I don't want to, we have the input data and we have the sample, the input data. I'm not sure why I need it right now, to be honest. So I'm not going to do the slicing and actually can compute the, what's called, the indexes without the sub slicing, and probably that should be easier. So I will have just this one, and then I will calculate the start I, start j, and this one, and we will implement this one. So don't want to do this. Okay, so here actually instead of the kernel data, I will use the input data. Okay, but okay, so the thing is that I need to have the pool size to calculate the maximum pool data, and it's accept the metrics. The thing is that I cannot just okay, I cannot just use the default slice. Okay, so for example, imagine that now I have something like this, wait, and I need to take this 4. Yeah, but in the memory they will be not like this, because it's the every row goes one after another. So in the memory they will be like this. No, and so this is how it's going to be in the memory. So I cannot, just take the, where is this one? I cannot use the, data, and no. I cannot do something like this, right? I will have to do it in chunks. So for every, and the thing is, well, actually, let's make even like this. Yeah, but what I have is the indexes of this one. So I need to generate some sequence that goes from this to this row, from this to this, and kind of outputs all of the indexes. Okay, let me just try it. So the max value actually will be like the slice. Max value, like how the slice, wait, how the slice API looks like. No. IKJL. So IKJL, right? And returns float 64. Oh. But also values 164, right? Missing return. Okay. I will take this one. And actually don't need this one anymore. What we're going to do? It's actually is equal to I, right? Then GL, right? So the max value is equal to max between the max value and values at okay, it's not actually that simple, and I will also need the n. So that's going to be I multiplied by n plus. Does it make sense? I don't remember if it tested tests. Okay, package, tests. Okay. Teams, tests, package. Okay. Fun test max value. Okay. So what I would have values. Then max I would assume utils max value. Okay, values. Okay, starting from first till second, and then third again till second, and we have 3 by 3, right? If max value doesn't equal to, okay, what I defined first line 2, so it's 4 5, and this, well, it's actually the second and the second line 7 8, so it should be 8, you know, T fatal F correct max value what? it should be like this, right? Including. Okay. One, two, two, two. Okay. Yes, it's actually should be 9. Then, okay, what if we change the array a little bit? So it's going to be, oh, it's actually the same. But the max value we will take from 0 elements up to first. Again, oh, no. First row, 0 element, second, wait. First comes rows. Yes, IK. First, second, then first. Okay, 0, 1, 0, 1. It's 1, 2, 4, 5. Okay. That makes sense. Which means that I can go here. Not this one. MaxPooling. Okay. So the pool value will be actually, this is going to be input data from I multiplied by the kernel count I plus 1. No, input size, again, input size, right? Okay, and then what we do, we have the start I and start and layer input size, right? Okay, so we have the pool value, right? I think that should be changed there too. And basically we have this one, right? So we have the value, which is the pool value. Well, not really. We have the patch, right? We have the indexes, so we finally can change the inputs, right? Don't need this. Okay, so for I think max this one. Okay, so the I is actually the start I, and we have the end, and that should be same start. So we have the layer, the inputs. Okay, we don't need this one. The inputs, same size as inputs. Basically, we need to check, like, if we need to check the mask. What is the mask? Mask is the, we take the input data and we compare it with, okay, so we go over this one, deal inputs. Then we take by C, I, and J from the values, and the value equals to the add, and here's the sample I, and then we have the same logic as we have here. So that's kernel I multiplied by 2. J. So we have this one, then we need to check the mask, and mask is comparing the max value to, so value is actually equal to 0, and then if full value equals to player input at then b equals to d value. Right, so, okay, so we take the d value, so we take this one from the d values, this one, if the current value for, if the value for the d input, okay, it's actually this one. Set apply. Okay, so there is actually a lot of the weird computations, and they're not, I mean, they're a little bit different between forward pass and the backward pass. But I don't know how to make it, better. Maybe in between the videos I will actually, make it more readable, because really this is hard to follow. I don't know what about you, but for me it's really hard to follow. The main problem comes with the way that I had to organize things. For example, okay, imagine, okay, so we have something like this. This is the output corresponds to kernel 1, no, kernel 2, and kernel 3. And if we and this is just the sample 0, so this is the 1, and then what we do actually is we do this. Wait. So something like this. We have the first sample, second sample, and so on, so on. So if we take a look at this, so it will be, and this is what I have as, for example, as the inputs for MaxPooling. It's called inputs, right? Yes. And for this one, I need to calculate all of the things. This is why I have to treat data differently, but it is what it is. Right now I don't have a better solution. But what it means actually is, since I'm done with the MaxPooling, and this thing, well, actually, let me check once again. So we have, wait, where's the backward pass? So this one is actually, we going through the output size, INJ, input data, so I think, I mean, for sure I have the mismatch with the indexes. For example, this one, I'm using the I and then I multiply by the input size, but then I create this one, but then I'm using the input data to get the maximum value, but right. Well, actually, no, I expanded it, so I mean, that should be fine. And then I'm going through another internal index, and I need to set the D inputs. I mean, I need to take the D inputs from the D values that comes into the forward path based on the maximum pull value. So I only propagate the D values back to the convolution only for parts of the max pool, only for parts of the convolution where there was the max value. It definitely has to be checked. By the way, how many to-dos I have? No. Do I need to still? Okay, so I will clean this up. But it means I'm going to fix the backward pass. Well, finish the backward pass for device control max pooling. Okay, so that should be the same size. What it means, so the D inputs and the D filters will have the same stuff as the filters. It's actually the kernels here. It's GI. Okay, what I'm doing, I'm creating the several kernel. Okay, and in the forward, what I'm doing, I'm going through all of the rows. I'm taking the sample row and data, right? And this is what we output. So there is a kernel output that takes the kernel and the data, and there is an output, and when we edit, I mean, maybe I should have the kernels like this. Again, store it as one array and then treat them different. Okay, I will not change it for now. What means, so the D input is the same as the input data. That is easy to implement. Let's copy all the input data, right? For the D filters. Okay, so there is the D inputs and the D filters. The inputs and the kernels, which should be math dense, right? And we have the zeros like, so we have the layer, the kernels equal to make kernel counts and Okay. Kernel. Okay, so the initialization is done. Then what we're doing for the range of the number of filters, okay, 4. Well, that's actually the same. Okay, so for the D filters, for the kernels, we actually have the correlation between the input data. Okay, so that's a little bit different. Okay, so actually we have, well, I think for the forward path, so 4. This is kind of the same, right? So we have this one, row. So we have the copy sample. Okay, so we have the input data, right? Input data. And sample the values kernel, right? So kernel size. The interesting part is the data, right? So the D values, this one. Row view of I, and then we take j multiplied by the kernel size, j plus 1 by kernel. What's missing? Not used, right? Then we have the between the sample, right, and sample due, this one. And this one for the D filters. Okay, so I need to change actually the D kernels. It should be no same as the, so it actually should be the same as the D inputs. This one is interesting. It will be the sum, but this one I will have the same as the D inputs, because I will have lots of the input. What's called? I will have lots of the input samples, so I will need to kind of do do the opposite, right? I will need to compute the values for all of them, right? Or maybe not. Okay, I'm confused already. Gradient of the inputs. Yeah, but they will be lots of them, right? Okay, so that's basically the thing for the next video. I will continue tomorrow. I'm done with the MaxPooling. I almost done with the backward path for the convolution, which means that once I'm done with this one too, I will start and I will prepare some testing data so I can write some tests to test the convolution and the backward and so on and so on. So eventually, but I already feel like I will have lots of the a lot of debugging time to test all of the things. But I mean, that's fine. Why not? All right, but step by step, with the little steps, I'm going further, which is a nice progress. Okay, but for now, thank you for watching and I see you in the next video. Bye-bye.